Hey, this is Don from Padlock Technologies again with another video. This is going to be the season finale of labeling for MPLS networks. So we went over LDP, we did BGP, we did RSVP or MPLS TE, and now we're going to talk about segment routing. So let's get to the blackboard here, do the title, segment routing. Now, what is segment routing? So this is not a, I won't say this is a brand new technique because this has been around for a long time, but it's fairly new to people that are from the CCIE world, right? The CCIE enterprise or route and switch as it used to be called world. Segment routing is basically a technique that combines two things together so you don't have to use one of them. So basically, in the traditional MPLS network, you're going to have an IGP, BGP, LDP. All right, that's basically the three ingredients in your MPLS network, right? Now, from BGP standpoint, you're going to have either VPN v4, R6 if you're doing MPLS, L3 VPNs, and then you're just going to have targeted LDP if you're going to do MPLS L2 VPNs, all right? But you still need to use LDP in this function, unless you're using, like I did in the last videos, MPLS TE, which is going to use RSVP. All right, now you're not going to use BGP to do the labeling because it's just, if you're not doing inter-AS L3 VPNs, which I'll talk about in a later video, you're normally just going to use LDP, right? You're not going to use BGP unless you're doing like seamless MPLS. I did a video on that as well, seamless MPLS, but LDP is what you're normally going to be taught, right? And that's another protocol that you're going to put on top of your IGP and BGP. Well, BGP is not going to be involved other than the sharing of NLRI, but you're going to need that LDP for the IGP. Now, if you're doing something like MPLS LDP sync, which is going to use, you're going to use that to prevent black holing for things like if a label doesn't pop on. But this whole thing here for syncing is basically saying don't have an adjacency unless LDP is neighborship has been established. Now, what segment routing does is it removes LDP and it allows the IGP to actually do the labeling. All right, so you're going to get the label in the IGP, and the IGP is going to carry the labeling information. So when you do show MPLS LDP neighbors, you won't see an LDP neighbor, right? But you'll have a label when you do show MPLS forwarding table or show MPLS forwarding. You will have a label, but that's going to be done by SR or SR, which is segment routing. And I'll show you that in the lab where we're going to use ISIS because it's easy for me to show you in ISIS. When we look at the ISIS database, we can look at the prefix SID, and then you'll see a N and I have a 1 next to it. And that means it's just that's the prefix SID or the node SID, if you want to call it that as well, which segues into that topic. So in segment routing, you have a prefix SID or a node SID, all right, segment identifier, and then you have an adjacency SID. Hopefully I spelled that right. SID, right? So the node SID or adjacency SID is usually the loopback of the node, and then the adjacency SID is the links for the links, right? So in segment routing, you're routing towards the node itself, right? So the node itself, when you look at the labeling, you're going to have a node label, and everyone has that label. If you're using absolute value, if you're using index value, you have one node say, okay, I'm going to use index value 1, and then you have somebody use index value 2, and so forth and so on, right? But usually best practices, at least in my opinion, is to just use the absolute value for the prefix SID, and then the adjacency SIDs will be automatically generated, and that's fine. Right. So you're going to be from a transport standpoint, you're trying to get to the node. Now, there is a topic that people like to talk about, which is loop-free alternate. And loop-free alternate is basically having a burnt-in path for convergence after, you use BFD to recognize the failure. Now you already have the backup path in your routing table ready to go because of the loop-free alternate, right? Now, there's loop-free alternate, so LFA, right? That's from the router you're doing LFA on. So router, right? RLFA, which is from another router. And you got TILFA, which is SR specific. And what this involves is P nodes, Q nodes, and PQ nodes. Now, I'm not going to get into that because that's going to get into convergence, and that's a whole separate topic. So just know that there's a P node, PQ node, or P node, PQ node, and the P node, Q node, PQ node, basically. So this, in a nutshell, the P node would be where like routers I can reach. All right. The Q node is routers closest to the destination. And the PQ node is the mesh between the two. So if I can reach it, I can reach, and it's close to the destination, then I can tunnel traffic over there, right? And I can force traffic that way. And the only reason why you can do that is because of this adjacency SID, right? So what you can do is you can force traffic in SR to go to a certain link, not just the node itself. You can say, okay, go, say it's 6 routers. I can say go to router 4 and then go on this specific link on router 4. So you can actually force the traffic on a link basis and not just go to the node itself, right? And that is with the adjacency SID. So from a segment routing standpoint, it removes LDP, allows you to carry the label in IGP, and then you still have a new concept called a prefix SID and adjacency SID. From a convergence standpoint, you're going to use TLFA. This is going to give you 100% coverage. This is less than 100%, so less than 100%, and this is even less. So LFA gives you some coverage. Remote LFA gives you less than 100%. TILFA gives you 100% coverage because you can force things through that adjacency SID. Is there anything else I'm missing from a MPLS standpoint? So no. So that's segment routing in a nutshell. This is a broad overview of segment routing. If you are trying to get into it, I suggest you read some of the books on segment routing. But this is good enough to get you started, at least from a theory standpoint. Now, there's more theory in there. There's Anycast SID. So Anycast SID is basically a node SID that removes this thing called an N flag. So if you don't advertise that N flag and you both have the same loopback, now you're doing, let's say loop back here. Now you're doing redundancy from a routing perspective because I'm not advertising my N flag. So if you're not advertising the N flag, that N for 1 would be 0. So then you have Anycast SID. But that's segment routing in a nutshell from a theory standpoint. The next video that I'm going to show you, it's going to be in the lab. Now, it's going to be the same lab as I showed you with MPLS TE, but this time it's only going to have it's going to have SR in it. So MPLS SR, but it's not going to be MPLS SR TE. That's a totally different thing. And you need to use like iOS XR routers to properly do that, because then you have this thing called an opaque community value. And then you can do on-demand tunneling and stuff like that. That's more on the SRTE side. So I'm going to do regular MPLS SR. And then if you want to see MPLS SRTE, put it in the comments, and then I'll work up a video about MPLS SRTE, which just resembles MPLS TE, but just use segment routing on top of that. And then it has this concept called PCE or in PCC, which is path computation client and path computation element. And with the path computation element, that is like SDN light, because now I can tell the PCE, hey, give me a path to whatever destination. And because the PCE knows everything about everything in every environment, it can do the calculations, it can do the path calculating for me and give me a path to whatever destination I'm trying to get to. So that's a lot that I just said, and that's why I'm going to keep that in a separate video. But if you want to see MPLS SRTE, put it in the comments. This is Don from Padlock Technologies again. I hope this video was informative. Don't forget to share, comment, like, and subscribe. Thank you, and have a nice day.